Hello all and welcome to this video on solving equations with matrices. I'm going to try and move through this very quickly because I just recorded this whole video but forgot to hit the start recording button, and that's why I'm checking yes it is recording. So bear with me, I'll try and get through this nice and quick while covering everything. Now, I've been talking about in class building two matrices are really useful because it allows us to solve equations. Okay? And we're finally here. We're finally going to do it. Okay? Now we're going to do it with really simple equations, but like I talked about, matrices are really powerful because we can use them in much bigger scales, so 3x3, 4x4, 5x5, 6x6, up to whatever size we want. And then they became super powerful when computers came along and could do the process really quickly for me. Okay? Because computers we can program to do matrix operations, and so it becomes really quick. So matrices got a lot of use. So let's have a look, and let's start with the most simple form of simultaneous equations. Two equations with two unknown variables, x and y. Okay? We can solve them using methods we've learned earlier, but like I just said, we can do it another way. We can do it with matrices. Now the first trick with it is when we rewrite. And what we're going to do, on one side of the equal sign we turn into one matrix, and on the other side of the equal sign we turn into another matrix, just like we have here. Okay? Now the next step is conditional. We only do this if all of our variables line up. Okay, all of my x's are first, all my y's are second. If I had a 3x3, I'd have all my x's, all my y's, and then all my z. Okay, if they are all lined up, we can split it where the variables get put in one matrix and all the coefficients get put in the second matrix, in the first matrix. Okay? All the coefficients come out, they're by themselves, all the variables get put in another, okay? And then our solution just stays the same. If you did this matrix multiplication, okay, if we multiply this A matrix by this X matrix, we would get this. Okay? This works in reverse, that's complete. Okay? But the shortcut is get all your variables in a row, okay? In a row, in a row, in a row. You can take the variables out as their own matrix right here, and then all the coefficients here. Okay. Now plus y, that's saying plus 1y, so we get 1 as a coefficient. Minus y, that is minus 1y, so we have negative 1, just to be clear. And what we've created, we call this first one with the coefficients, we call that A. Our matrix with the variables, we call that x. And then the answer to those two equations was what we call B. So we've created a now problem. If we forget everything above this line, we've now created this problem. AX equals B, where A is a matrix, X is a matrix, and B is a matrix. So if we continue on this thing, okay, I just have now, we forget about the simultaneous equation we had before. I just have a matrix A, matrix X, and matrix B, and we know this holds true. What I can do, okay, is I can solve this by performing operations on both sides. Now, if I was doing this, if it was algebra, okay, and I'm going to use small lowercase here, if I had AX equals B, what I'd do is divide by A, divide by A, they cancel, so I have X equals B on A. Now, the other thing I can do though, again, if I did algebra, B, I can multiply by the inverse of A. And A times by its inverse, this is the beauty of an inverse. It's anything multiplied by its inverse becomes 1, so it cancels. So we get X equals A, inverse of AB. And if we use our index laws, that is B, A, which add up here. The same thing holds true with matrices. Okay? We've talked about in class, we don't divide matrices. What we do instead is we multiply by its inverse. Okay? We do this version, we don't do this version. It gives us the same outcome, we just saw that. It gives us the same outcome, but we're going to do it by multiplying by its inverse. So if I have A, X equals B, I'm going to multiply the first side, left side by the inverse of A, and right side by inverse of A. And here we've talked about it, A, inverse of A multiplied by A gives us the identity matrix. Now, as a quick reminder, the identity matrix is that matrix where it's all the ones just on the main diagonal and everything is zero elsewhere. Okay, and that is effectively the matrix version of 1. We multiply an inverse by itself, it gives us the identity, or it gives us, okay, that multiplied by that gives us the identity, and the identity is effectively 1, so we can cancel out, and we're left with x equals the inverse of A multiplied by B. That gives us x. If we do this, that gives us x. And what is x? That is x and y. If we do this thing, it gives us the solution to our equation. So in this occasion, using this example up here, okay, the inverse of A equal to this. I'm not going to go over how to find the inverse. We've done it before. Get that. Now if we then bring that in here, okay, and then multiply by, this is B, the inverse of A. We multiply all these together, either by hand or by calculator, we get this solution. 1 on 5 and then 8 on 5, which is, okay, our x, which is x and y. That's our x value, that's our y value. Okay. Like I've said, doing it by hand, tedious. Calculators, computers, awesome, makes it super quick. It's what you would do outside of school, but we need to make sure you can do the process by hand so you understand what's going on. So let's do some examples. This one, I have 3 equations and I have 3 variables, so I can have a go at this. Okay, if I have more variables than equations, then we can't do it. We run into problems. So let's have a go. Let's build our matrices first. We get 2x plus y plus z equals 2, 3. I'll fill those in first. We have half x minus y plus 4z, and we have 2x plus 13y, and there's no z, so we need to add this in. We need all our variables to be in line, so we're just going to call it plus 0z. Plus z. So I can now, because all my variables are in line, all my variables are in line, I can say that's the same as 2, 1, 1, half, -1, 4, 2, 2 on 3, 0. So I'm just pulling out all the coefficients, yeah? 1y, 1z, -1y. Pulled out all the coefficients. Now I pull out my variables equals 2, 3. We now have that ax equals b. So following on from the previous slide, take this over here because we want to get x by itself. That is the inverse of a multiplied. So it says help with CAS. So let's, instead of doing anything else further, we have to do this bit by hand. We have to break down the matrices into this format. But once we've done that, we can do this whole bit by hand. Okay, we can find the inverse by hand. We can multiply it by b. We can find the inverse by a calculator. We can then multiply it by b using a calculator, and we can get our answer. So let's have a go at that. Right. New page. Oh. Okay, so first off we need to store our matrices. So A, and then to store it's control, blue button, and this button over here. Okay, that gives me this store. Then I need a matrix here, and I need a 3x3. So I have to, there's two options here on your calculator. There's 2x2, which is just locked 2x2. And then this one over here is called an n by n, because you get to choose your dimensions. We need this one. So choose that one, hit enter. I want 3 rows, I want 3 columns. Press tab to go through them. Enter to select. So I just fill it in. 2, and then press tab, go to the next box. 1 tab. 0.5 tab. -1 tab. 4. Keep repeating. Okay, that's stored as A. Now I need to store B, because I'm going to do this over here. So same thing, B, control. Now again, I need a matrix here. I'm n by n because I don't need a 2x2. I need a 3 by, and in this time, I need a 1 column. 1. Okay, and I'm going to show you something. If I haven't filled this all the way out and I hit enter, it gives me a syntax error because I can't have an empty box in my matrix, which is really handy. 3, enter, stored. Okay, so I've stored A, I've stored B. But I don't need A, I need the inverse of A. Oh, wrong things. Oh god. Okay. How do I get the inverse of A? Well, it's really quite simple. On our CAS, we A the power of -1, there's your inverse. Done. We're fine to the determinant for us, multiplies it through, does everything. There's our inverse. But we're not going to write it down, then write B, and then multiply them. Let's just do it all in one go. Be efficient. A to the power of -1. Press arrow across to just get out of the power. Times by B. There's our answer. Okay. So we get this to write down. What are we? 1.8, -0.9, -0.7. So we get equals 1.8, -0.9, 0.8. Okay, that was x, which was that over here, x, z. So x is equal to 1.8, y is equal to -0.9, and z is equal to -0.8. All done. Easy. Okay, break down our matrices. Use the CAS to store your matrices, and so you've solved your simultaneous equations. Haven't had to do cancelling, haven't had to do substitution or elimination. Done. That was with CAS, made it nice and easy. Let's try and do one by hand. Okay. Bit easier this one. 2 equations, 2 unknowns. Thing we should note though, this is not in the standard form of equation. We've got variables on both sides. So let's fix that and turn this into 2x plus y. Okay, I've just moved side by 2x. So I'm going to use this one now. I'm not going to use that. Let's write matrices 2x plus y, x minus 3y equals 3 negative. Okay. Turns into, because all my rows, so we get 2, 6, 3, 8, 3. So we now have A x equals B. So x is equal to the inverse of A. Now, we're going to do it by hand, not by calculator. So how do we find the inverse of A? First, we need the determinant of A. So let's get that determinant of A. And if we remember back to previous classes, the determinant of A is the main diagonal. Multiply that together, and then you subtract the other diagonal. multiplied. So we get 2 by -3, subtract -6 by 1, that gives -6 plus 6 is equal to 0. You should hopefully be thinking that's an issue. Okay? Because if you remember when we looked at inverses, if the determinant is equal to 0, there is no inverse. Now what does that mean for this? Okay? If there's no inverse, that means this doesn't exist. Now if that doesn't exist, that means this whole thing doesn't exist. That means this doesn't exist. Okay? So if there's no inverse, and when we're trying to do this, that means there is no solution. Okay? And the same would hold if you tried to solve these using elimination or substitution. You'd just get a whole bunch of everything being wiped out and zeros everywhere. Okay? And if you look really carefully, maybe someone might have noticed, okay, this first equation, okay, and then this second one, this second equation is just the first one times by -3. So because it is just a multiple of the first one, we can't use it. We can't use it to solve it. It runs in all sorts of errors if you think back to simultaneous equations. So there's no solution. So we can't do that one by hand. So we go on to our next problem. I'm going to show you this by hand, but you can also do it by CAS really quickly. The admission fee at a small fair, and this is a worded problem, so I'm going to look at some worded skills. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people entered the fair and $5,050 is collected. Set up simultaneous equations. Use a matrix method to solve for how many children, how many adults attend. So the first thing off the bat, any sort of worded problem, we identify what do we have to give at the end. How many children, how many adults. They're the things we're after. They're the things our variable should be. Okay? So I'm going to let x equal number of children, okay, and y equal adults. And I didn't write just y equals adults, because what is that? Cost of adults, like it's not clear. You need to really clear. So y is equal to the number. You start doing cost or not being clear, that's when people make the very common mistakes in forming incorrect equations. Now that I know x is the number of children, let's use that. Okay. So all of the children that come in times by 1.5 plus all of the adults that come times by the cost of 4 is equal to the amount of money that we brought in, 5,000. So that's one. And then the second equation is all the children that came in plus all the adults that came in is equal to the 2,000 people added. So I have now two equations with two variables, so I can solve. Let's form it in a matrix, and I'm going to jump straight into a preferred form. I'm just going to put the coefficients in 5 and 4, and then x and y. Well, that's 1x, 1y, y equals 1050, and I have ax b. So what do we go from here? So going that we want is that. And I'm going to check I'm still recording. Yes, lovely. Okay, so we need the inverse of a. So first we need the determinant. So that is equal to the main diagonal subtract the other diagonal. So 1 4 by 1 to negative 2.5. Now in a minute I'm going to turn this into a fraction, because if we're doing stuff by hand and doing decimals and multiplying by decimals, running all sorts of problems, it's better to have it at, we're going to turn it into a fraction, but I'm going to leave it for now and I'll turn it into a fraction in a second. So the inverse of A is equal to 1 on negative 2.5 by, flip the main diagonal, okay, and then the other diagonal made negative. So this is where I'm going to turn this into a better fraction instead of having a decimal. So 1 on negative 2.5, this 2.5, I get rid of it by multiplying it by 2. So I'm going to multiply my numerator and denominator by 2. So I now have, that is the same as negative 2 on negative 5. Now I'm going to do the scale multiplication. Get 5 on 5 like this, 2 on 5 negative, and 1 on 5, that's this 1.5 is the same as 2, so I use 3 on 2 there. That's going to give me negative 6 n. That's my inverse of A. So it follows on, x is equal to, we just found, multiplied by B, which is over here. Now if we do this matrix multiplication, we're going to get, well, what do we have first? We have a 2 by 2, okay, times by a 2 by 1. Okay, so that works as this and this are the same, so we're allowed to do that. Okay, so that works, and that's going to give us matrix that has, that is that dimension, 2 by 1. But I'm going to draw it nice and big to actually give me some space to multiplication. So my first element is going to be the first row times by the first column, negative 2 on 5 times by 1050 plus 8 on 5 times 1200, and then my second element down here will be the second row times by the first column, 2 5 5050 minus 10 by 1200. Okay. And if you do that, you get 1500 and 700. That is equal to x, which is this, which is x, y. Now, worded problem means a worded solution. The number of children was 1500, and the number of adults was 700. All done. Now that's a bit messy. That had some fractions all through it, okay, and then some multiplication by some large numbers, but you just showing you can do it by hand. Now you can also do it by CAS, and I think I have it on another page. Okay. No, I don't have it saved on the but you can do it. You definitely can do it on CAS, just like the problem we did before. Okay, and that now brings us to, you need to do this worksheet. Okay, 26E worksheet, you'll be able to approach that now. Now, to sum up, what did we do? What did we do? It's all a bit messy, but the key thing came down to, if we have simultaneous equations, okay, and we order our variables in a line column-wise, we can break it down into this matrix problem where we have a matrix multiplication. To solve that matrix multiplication, we take the inverse of something, okay, which is this bit here. Okay. X is equal to the inverse of A, and we can do that. And then we either do it using CAS or by hand. Okay. Finding the inverse like we normally do, and then multiplying it by B, either how we normally do, or we can do it all on the CAS. And these were the examples. Okay. The key thing was, though, that all our variables need to be in a row vertically. We can't do that for some reason, or the determinant equals 0, then we can't do it using matrices, and half the time there's no solution. If you have any questions, hit me up on Edmodo. But yeah, in class we're going to be working through that worksheet.